So for this project, we were tasked with making a glider that fit into a 16-inch by 16-inch box and was capable of traveling at least 20 feet. In our initial discussions in making the glider, we discussed the best ways to increase the distance that a glider could travel with just being hand thrown. We came up with two main things to do that: increasing the aspect ratio of the wing, which would increase the lift to drag ratio of the plane, and making the glider as heavy and as aerodynamic as possible. The former, increased the lift to drag coefficient and meant it could fly further with the same amount of initial thrust. And the latter made it, since it was heavier and had a lower drag coefficient, it would resist slowing down as much as possible, which would allow it to fly faster, going further, and produce lift for longer. So for the design process, some alternatives we picked. So here you can see our initial design. Some alternatives we considered. We considered a different wing shape. We ended up with we chose a high taper wing, but we considered an elliptical wing shape and a dihedral wing shape. But we ended up settling on this high taper wing shape for reasons we'll discuss in a second. Wing placement, we discussed where best to put the wing. So we thought we had three options. We had a high body wing on top of the fuselage, a wing through the middle of the fuselage, and then the low body wing that we ended up settling on. The third alternative we thought about was the tail configuration. Here in the initial design, you can see that we have a horizontal stabilizer and no vertical stabilizer. We considered that. We also considered a two vertical stabilizer approach like the F-22 has, because that would look really cool. We ended up settling, however, on a horizontal stabilizer with a vertical stabilizer on top of it, as you can see in our final design down at the bottom there. So the pros and cons of the alternatives with regards to the design requirements. So for the wings, we thought the pros of the wings we chose were that they were easier to manufacture and they would have slightly higher performance. So I guess the cons of the other alternatives were that they would have a worse aspect ratio, which we thought would decrease the performance a little bit, and it would be harder for us to manufacture with the tools that we had, because we cut them out by hand. The tail wing, the no vertical stabilizer would have been easier to make, but in testing, like our very earliest testing, it was completely unstable in the yaw and in the yaw direction, and we really couldn't get it to go straight at all. So we needed a vertical stabilizer. And then in the wing placement, we thought low body. When we were making the wings, we flip the plane upside down, glue them on top, and the wings kind of have a tendency to fall a little bit towards the edges. So when the glue dries and you flip it back over right side up, you get with wings with a slight upward camber. I don't know if that's right. A slight upward tilt to them. And we figured that would increase the dynamic stability of the plane, which we wanted, because we didn't really want a whole ton of maneuvers from the plane. All we wanted was it to fly straight and far. The alternative with the highest chance of success we thought was the elliptical wing, because a lot of professional gliders have elliptical wing shapes, and they have a proven track record of being good glider wing shapes. So we knew we could have used it, and it would have worked well if we'd wanted it. We just thought that the aspect ratio of these wings would be slightly better. For the sizing of the plane, so our main idea for the sizing was we want it to be as heavy as possible, and we were working with wood with the same consistent density. So to make it as heavy as possible, we made it as big as possible. So we had a 16-inch by 16-inch frame to work with. I think it ended up being 15.5 inches long by 16 inches wingspan, with a 16-inch wingspan. So we just maximized as much as we could. And the bigger wingspan also gives us more lift. And then the nose ends up getting shaved off a little bit when we sanded it off to make it more aerodynamic. So the initial concept has a low body, high taper wings with a 16-inch wingspan, a singular tail wing, no vertical stabilizer, with a horizontal stabilizer, no vertical stabilizer, and a flat nose initially. And in initial testing, the glider was going 60 feet, which was 3 times what we needed for the requirements. So we were like, okay, that's awesome. Our final design is pretty much the same thing. We ended up adding a vertical stabilizer and rounding the nose off to make it more aerodynamic, as well as putting putty on the nose to increase the mass of the plane and to keep the nose stable. Yeah, so in regards to stability, the center of gravity is like almost exactly on the quarter cord of the wing. So we decided, so when you throw it fast, it has a tendency, the neutral point is slightly above that, slightly in front of that. The lift causes the nose to tilt upward a little bit. So that weight kind of keeps it pressed down and keeps the thing more level when you initially throw it. And then when it slows down, it kind of points the nose down so we can build speed back up so we can get into another glide phase. In terms of roll stability, it's completely stable in the roll phase, unless you throw it and you add a roll moment yourself, it won't roll on its own. We calculated the lift coefficient to be 0.996, and we calculated the drag coefficient to be 0.0165. We just used the equation. We just plugged the numbers we had from our measurements into the equations we were given. Some thoughts I had on how to improve the plane. I broke it the first time and I had to redo it, and some of the parts were a little bit damaged. Bad idea. Don't break it the first time. Also, if we made the body a little bit thicker, it would have been a little bit easier to throw and hold, and that really was what I wanted to do. Here is the proof of it fitting in a 16 inch by 16 inch box. I forgot to take the picture at the AMS. My bad, but I promise that is a 16 inch box. And here's the best throw we had.
You get out of your frame over here. Yeah. All right, let her.
As you can see, I accidentally threw it and spun it off my fingers, which imparted a roll moment. But it went 45, I think, feet off that one. Killed it. Blew past the expectations. I thought it flew great. If I thrown it better, it would have gone even further.